Be careful, guys, you can throw hands.
Yeah.
Today we're gonna talk about a function. So before we can talk about a function, we need to talk about a relation. What's a relation in, oh, that's kind of funny, huh? Relationships with your cousins. Anyway, so what's a relation?
Something.
It goes with something, okay.
Something that two numbers have in common.
Okay, so basically, this is going to be a set of ordered pairs. And they're kind of related, right? So what's a set?
It's a bunch of pairs.
So what's an ordered pair?
Two numbers that are alike. And they're in parentheses.
Okay. So my ordered pairs would be something like this, right?
Oh, yeah.
So what's a set of ordered pairs?
Two of them, so it'd be
Yeah.
like 2-3, and then it'd be another one to make it.
Something that you graph on.
So it'd be like,
Is that a set?
Yeah.
Everybody agree?
Yes.
Okay. Normally, this set is going to be shown inside these
Brackets.
funky little brackets. Okay. So a set, though, or a relation, is basically anything that I can relate to something else. Right? So we could do basketball, and we could say the number of free throws made compared to the number of free throws, right? And we could have that as a set. And we could do that for everybody on our team, and then we could draw a little line graph because of that, right? With baseball, we could do the same thing, right? How many plate appearances you have compared to the number of strikeouts you have, or whatever, right? So we can relate just about anything we want, and we're going to show this in ordered pairs. Okay, so when we then move on to this word, a function is a special relation. So what makes a function a function? It's special because why? Well, first off, let's go back and talk about words that we're going to kind of wrap up into all this stuff. A special relation, okay? A relation is a function, but a function doesn't have to be a relation. Make sense? Okay? So a special relation where the x's, okay? Hold on. What do we call the x's? The domain. Okay.
Why is the range?
But, so it's a special relation where the x's, or the domain, okay, is paired with exactly one y. Or what'd you say it was?
The range?
The range. So they can only occur one time with a domain. So this means when I do this, if a relation is a function, all the x's will be different. So pretty simple, I can look at a set, and I just look at all the x's. So I'm looking at which number in my ordered pair. Which one's the x?
2.
The left-hand side one, right? This is always my x, and this is always my y. Okay? So, if a relation is a function, all x's will be different. So again, is every relation a function, or is every function a relation? Every
Yes.
function is a relation. Not every relation is a function. So a relation is just a group of ordered pairs. But a function is a special. Alright? So, example here, sorry. Number 6 and 7. Turn the page, get your book out, turn to page 371. And we'll look at that. So on page 371, we would look at number 4 or number 5. Okay? So the first part they're going to say, is this relation a function? So in number 4, don't say anything out loud, let everybody have a chance to think. Would you say number 4 is a function? What do you think? What's a function? Are all the x's different in that problem?
Yes.
No.
Oh, wait, no.
No, there's two
No,
thirteen.
There's 2 13s, right? So, is it a function?
No.
No. All the x's will be different. Let's put another star here though. The y's for the range can repeat. So the x's all have to be different. You can have all the y's be the same thing. How about number 5? Is number 5 a function?
Yes.
Because all of them are different, right? How about number 6?
Yeah.
Again, we're looking at the which one?
The X.
The domain, right? Or the x, the domain. Okay? How about 7?
No.
Because of
Two.
2 5s and 2 2s. Okay? So we had 2 things, right? So, again now, we could do this in multiple ways, right? We could look at sets of ordered pairs. What would we call 6 and 7? Tables, okay? So they might ask you to do or show a relation. So to show a relation, we could use ordered pairs. We could use a table. And in these tables right here, we did them vertically, like this. X and the Y, they use domain and range. But you could also do it horizontally, like this. Now, I don't care how you do these when you start doing these. But myself, I prefer these, ones that go up and down or vertical. Just because then when I look at these numbers that I put into the problem, our first one was 2, 3. I could put parentheses around them and they look like an ordered pair. If I had that over here, yeah, it's still showing my X and my Y, but to me that doesn't look like an ordered pair. That makes sense? So again, you can do it however you like it, but I always kind of go for this one. Another way to do this would be by graphing. So when you graph a relation, you're going to plot your points. And then they don't show it in this, but sometimes you could use something called a mapping. And again, they don't really show this in our book, but you'll get introduced this to in algebra more, okay? A mapping is kind of like big ovals here. And then they would have some numbers in this one, and they'd have some numbers in this one. And then they would just start drawing like lines across, and when the lines hit each other, they would form an ordered pair. Okay? So that's just another way, which we don't really have to know about that way. Okay? So, then we go over to number 8 and number 9. In number 8 and number 9, another way, so we're going to, this would be how to test a relation by looking at the x's or the y's. If you do a graph, you can test a graph by something called the vertical line test. You'll hear this maybe in your those tests that we're gonna take here sooner or later, the ISAFs tests. Yeah, the Iowa assessments, okay, or this might end up on your STAR math, the last time we have to do it. If they tell you to take a vertical line test, first off, which way is the vertical line?
Up and down.
Up and down, right? So I could take my pencil in and put it on my graph, and if my pencil only hits each of the dots or the line one time, then we would say it's a function. Okay, so that's what the vertical line test is. So would you say that number 8 is a function? If I put my pencil on there and touch every one of those dots, does it only touch one dot at a time? Kenzie says no. Where would it hit? Multiple ones. Yeah, those bottom 3, right? Because if I put my pencil on what I would call x is equal to positive 1, it would hit 3 of those dots, right? What about in number 9? If I took my pen or my pencil or whatever and kept going across that graph, would it ever hit that line more than once? No, right? So is number 9 a function? Yes,
Yes.
because all of my x's are different. So this is just a different way of kind of showing that or proving. All right? Questions here? So then they talk about describing your relationships. Well, what's that mean? Well, this is kind of what we talked about earlier with the basketball or the baseball or whatever you wanted to do. How are we relating the information? Okay, so to relate this now, you're probably not going to do this a whole lot, but if you have to, maybe you have to do this for a college class or even another class here. To relate this, one way that I'm going to do this is always use headings. So you should have a heading across the bottom, and you should have a heading along the side. And the headings just tell everybody what it means. So when they would open up and see your information, they could see that along the bottom was the number of free throws that I attempted, and the one going up was the number that I made or missed, or whatever. And then where the dots connected, we could tell the amount of both. Right? But if I don't have a heading there, and I just look at a chart, I might have no clue how or what it's telling me. So it's just kind of a clue to let everybody know. Right? So, essentially, that's it. Okay? So you're going to do these functions and go through them just like we did here. So basically, this assignment, you're just going to say, can I do this? Or, not can I do it, but is it a function or not? And if it's graphed, then I might use this vertical line test. Or I just look at if the x's occur more than once. That's a way of doing it every single time. Okay? So today's very, very simple, hopefully. Hopefully we get off to a good start. All right?
Is it a lot of problems?
I don't believe so.
For the question, do you put like, if it's a function, do you say like, yes, it's a function or no? So like, how would you put that? Just yes or no?
Yes. No, if you have to say no, then you would probably say because it has two
Okay.
fives. Okay?
Mr. K,
Yes.
so are you the head coach of the